Hi and welcome to the On Maths prediction for the AQA GCSE Maths paper Foundation Tier, Paper 2. This is filmed after Paper 1. Enjoy! Hi, I'm Chris Gilpin and welcome to our prediction for the AQA Foundation Paper 2. Now, the way we've created this prediction is we've taken out all the topics that came up in your Paper 1 and have looked at what is likely to come up on a calculator paper and probably won't. So the non-calculator topics, such as multiplying two numbers together, well, that's a bit easy now because you've got a calculator and adding fractions becomes a lot easier. So if they're going to ask that question, they do it in a slightly different way. So we've created this paper on our website onmaths.com. If you want to do it on the website, what's beautiful about the website is all the numbers change every time you do it. So you're not going to be remembering answers, you're going to be remembering methods, and that's going to help you with your exam. It will also grade your exam when you do it on the website. So you can see roughly and very roughly kind of what grade you're at with it. If you sign up on the website, and it's all free, everything we do is completely free. If you sign up on the website, then it saves your scores. So you can try it today and then come back tomorrow after a bit of revision and see how much better you're doing. This video just goes through the entire paper. Obviously there's only one permutation of each question. On the website it changes each time, but you should be able to see the method. So if you're doing the paper on maths.com and you're a bit stuck on a question, then come back to this video, and there's a link on our website for this video, and there's a link on the paper. So when you click on the paper, there's a link that comes up and you can have a look at how the question's done. And so on the onmaths.com website, there's every topic. We do topic busters that cover the whole GCSE. So if you feel there's a topic that didn't come up in this paper that you want to practice, it will be on the website. There's also a multiple choice exam called Minute Marks on our website. Now the AQA does have some multiple choice questions, so that's really to help AQA students out with those types of question where you're given 4 answers. This paper will help you, apart from the fact that you're not given a multiple choice grid, but you should be doing the same processes anyway for the multiple choice questions. So hopefully you find this video useful. If you do enjoy this video, please click like. If you really enjoy it and want to see more videos from us, please click subscribe. Enjoy. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder, so you're just going to write 5026, 5026. Next question says write down the value of 8. Now if we remember, and let's just write the number a little bit bigger, this is our units column, this is our tenths column, and this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths. And that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655, if we just do a quick number line, 655, the next 10 up is 660, and the next one down is 650. So those are the two it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. If I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think, personally, it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there. We've got one across here, then we have a diagonal one here, and then we've got another diagonal one here. So it has 4 lines of symmetry. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, well, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well, that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. The first thing to look at with a pictogram, which this is the key. Now the key tells us what each picture represents. So if you have a look at the key here, it says each circle represents 8 DVDs. Now that's the complete circle. So it says what day are the most DVDs sold, Monday, Tuesday or Wednesday? Well, or you can always just look at which has the most shapes. Now Tuesday has 2, Wednesday has 1.5, but Monday has over 2, 2 3/4. So it's definitely going to be Monday, because it's got the most circles. Now, how many DVDs were sold on Tuesday? Well, if each circle represents 8, there's 8 there, and there's 8 there. So we just need to add the 8s together, which makes 16. So 16 DVDs were sold on Tuesday. It says how many DVDs were sold on Monday? Well, you've got the 8 there, and you've got the 8 there. Now we've got a bit of a problem here, because it's not a complete 8. So we need to figure out how much each quarter is worth. Well, what do you times by 4 to get 8? Well, 2. Let's check to see if that works. So we've got 2 there, 2 there, 2 there, and an extra 2, which is actually missing on that one, would make 8. So that would work perfectly. So to find out a quarter of it, we just divide it by 4, which gives us 2. So we've got the 8s, because we've got 2 complete circles, and then we've got those 3 2s, so we've got another 6. So we just need to add on 6 to the 16. So 16 plus 6 is going to be 22. So that's going to be 22. Okay, let's have a look at the next question. On Thursday, 20 DVDs were sold. Show this information on a pictogram. So let's have a think how many circles that will be. So if I've put 1 circle down, that's 8. Well, we've still got enough left over. If I put another full circle down, that's 16. Now 16, let's try another one. Let's put another full circle down, and that gives us 24. So that would be too much. So we're going to have to go into those quarters. So we've got 16. How many more 2s do we need? So 16, that would give us 18, and that would give us 20. So we need 2 whole circles and then 2 quarters. So if I shade in, if I draw, then shade in, 2 whole circles, and then we've got 2 quarters left over, which is just a half. Let's just check that. What's half of 8? That would be 4. And what's 8 plus 8 plus 4? That gives us 20. So we know the answer is correct. Okay, so this question is basically asking you to find 9% of 16,750. Now, because it's on the calculator paper, there's a much easier way to do it using the calculator. Without a calculator, you'd work out 1%, and then you times that by 9, or work out 5% and 4% and add them together. But with a calculator, you just need to know that percent means per 100. So 9% is the same as 9 over 100. Of just means times, and so all we need to do on the calculator is do 9 over 100, so fraction button, 9 over 100, times 16,750. And that gives us the answer of 1,507.5. So in money, that is £1,507.50. So the first thing to look at in this question is how many sides has the spinner got? So we've got 1, 2, 3, 4 equally sized, equally spaced out sides of that spinner. So any one of those colours is going to be a quarter chance. So let's have a look. What letter on the probability line represents the probability the spinner will land on a yellow? So there is 1 yellow on that spinner, and so therefore it's going to be a quarter chance. So if you have a look at how many notches this number line has, well, we don't count the first one, so we've got 1, 2, 3, 4 notches. So each one of those notches is going to be a quarter. So 1 quarter will be at B. Which letter represents probability of landing on a red? So we have 2 reds there. So that's going to be 2 quarters. So we've got 1 quarter and 2 quarters would be at C. Now 2 quarters is the same as a half, which is what the 0.5 there is. It's just a half. What letter on the probability line represents the probability it will land on a blue? Well, there aren't any blues on there. So however many times you spin it, it will never land on a blue. And in probability, we mark that with a 0. So it's going to be A. Alright, so the first place to start on this is to plot the points. So point A is at -3, -2. So along the corridor and up the stairs, well, we're going across -3 on the x-axis, which is this one here. And then we're going to go down 2 on the y-axis. So it's this one here. A really common mistake is to muddle them up. So as long as you remember you're going across and then up or down, obviously if it's a negative you go down, then you should be fine. Now it says point A, so I probably should label that as A. And point B is 0, 3. It means we're not going left or right at all. We're just going to stay at 0, but we could go up 3. So it's going to be there. And point C is at 3 -2. So along 3, down 2. Which could be that one there. So that's point C. and it says plot and join these coordinates. So I'm just going to get my ruler and plot and join them. Well, we've plotted them, so we're just going to join them. And there we go, makes a nice little shape there. Now, question B says, what type of triangle is ABC? So, looking at it, it looks like this length here and this length here are exactly the same length. So, when we've got a triangle with two sides the same length, it's an isosceles triangle. And try and learn the spelling of isosceles, because it does look better when you spell it right. I remember it's ISOSCELES. The SOS is like a Morse code thing to get help, save our souls. So I've always remembered SOS, as in, oh my goodness, I don't know how to spell isosceles. The easiest way to order decimals is just to put yourself a few columns down the page, and hopefully I'm going to try and get enough columns. I always end up with not enough, so if I put some extra ones in, that should suffice. And just literally put the numbers in, so 14.828, and make sure the decimal points are lined up. So 8.60 is going to be like this, and I'm going to put an extra 0 in to make them all the same length. It doesn't change the number at all. So 14.86, I'm going to put 0 in there, 14.820, and then 14.7. Now, we're starting with the smallest, so I'm looking for the smallest one first. Well, the smallest one's leaping out, because if I just look at this column, there's only one number that has a 0 there, all the rest of them have 1. So the 8.60, and I have to put the 0 because that's how it's said in the question, is definitely the smallest. So we can cross that out. That's definitely the smallest. All the other ones are tied. They're all 1 in that column. So we move over to the left, the next column, sorry, the next one to the right. So 4, 4, 4, 4, they're all tied. So I keep moving along. Okay, there's a clear loser in this one. There's a clear one that's the smallest in this one. The bottom one, 14.7. So that's definitely the next smallest. So I can cross that one out. All the other 3 have tied because they're all 8. So I move on to the next column. Now, looking at this, there's 2 2s and a 6. Now that 6 is definitely the biggest number. So I could fill that in as the biggest number. And we've just got to work out what the smaller of these remaining 2 are. Well, let's move on a column. And you can see here that 14.82 is the smallest or smaller of the 2. And so that leaves the 14.828 in that position. Now always just double check the 5 numbers you've listed are the same as in the question. That's the same. 18.60, that's the same. 14.86, that's the same. 14.82 is the same, and 14.7 is the same. You sometimes lose a mark if you haven't written exactly the same number. Same goes for when there's fractions and decimals. You've got to write down the number that it showed in the question. So for the first question, when you're adding letters together, the answer will be a number and then that letter. So we've got 1, 2, 3, 4, 5. So it's going to be 5b. The most common wrong answer is b to the power of 5. Now that's wrong because that only happens when you times them together, when you multiply them together. So it's going to be 5b for the first one. Next one is 10 lots of f, and we're taking away 3 lots of the f. Well, how many f have we got left over? Well, 10 lots of it and take away 3 lots of it means we've got 7 lots of it left. When you're simplifying one like this, in algebra we just don't use the times sign, so this is quite a nice easy question, 10ab. Now the last one is like terms, so we've got 5x here, and we're adding 5x. And we've got a 3y here, and we're taking away a y. So when you add the 5x to the 5x, you get 10x. And when you've got 3y and you're taking away y, which is short for 1y, so we've got 3 y's, taking away 1y, we're left with 2y. Now you can't simplify that any further because they are not like terms. You can times them, but you can't add or subtract them. So we're given function machines for this question, and it says what is the output when the input's 24? So the input's 24, and the first thing that's going to happen to it is it's going to divide by 2, so we're going to halve it. So that's going to make it 12. Then it says we're going to add 6. So when we add 6 to 12, we get 18. So the output is 18. Next question says below is a different number machine. It says when the input is 20, the output is 56. So let's follow through on the input. So the input's 20, we go take away 6, so that's going to give us 14. Now we've got to then think, right, how do I get from 14 to 56? Now, as it stands, there are multiple ways of doing this. If you do this on onmaths.com, it has a drop-down box and it only lets you select one of the options. So you can add a number to 14 to get to 56, and for this question that would be full marks, that would be absolutely fine. Or you can times it by 4, and times by 4 is the one I'm going to go for. So I'm going to complete the number machine by saying times 4. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here, because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want that 100 one. You'd also get 260. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all we need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27, and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. Question A seems like a really complicated question, but it really isn't. If you think about what you know about a rectangle, you know that opposite sides of a rectangle are equal. So if you just write down x plus 1 is the same as 12, and then solve it. So what we're going to do is we're going to take away 1 both sides. Then x equals 11. So we know that x is 11. Let's check that out. It says here x minus 1. Well, what is 11 take away 1? Well, it's 10. And that is the same as that. So we know that x equals 11. And that's it. Question B. Have a think about what you know. You know that all angles in a triangle add up to 180. So we know that if we add y, 2y, and 3y together, it's going to equal 180 degrees. So again, let's just get our lines down so that we can solve it. So 1y plus 2y plus 3y, well that gives us 6y in total. And then what we need to do is get rid of that times 6 there by dividing 6 both sides. So y equals 180 divided by 6. Well, I know 18 divided by 6 is 3, so I know that's going to be 30. This question is just asking you to work out 13% of 2,680, then work out 8% of 3,114, and then write down which is the biggest, okay, which person gave the most. So first of all, we want to do 13% of 2,680, and since it's a calculator paper, then we can do that by just converting the percentage into a fraction. So percent means over 100, and timesing it by the amount. So on my calculator, I will do 13 over 100 and times that by 2,680. And it might give you a fraction, just press the S to D button, and that gives me 348.4. And in money, that's 40, because obviously we do 2 decimal places for money. And I haven't shown the examiner who that is, so I'm just going to show the examiner that that's James we're working out. So on to Paul next. So we want 8% of 3,114. So we're going to do 8 over 100 times 3,114. So fraction button, 8 over 100. Or we could do 8 divided by 100. Gives you the same answer, 3,114. And that's going to be £249.12. So obviously James gave the most because that's the biggest number. So my answer will be James. And it says who gives the most to charity and by how much. So we need to work out by how much. So 348.40, take away 249.12. So 348.4, take away 249.12, and that gets me 99.28, so it's £99.28. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark. But if you actually wrote the gradient as well, then you definitely get the mark. And sometimes it will ask you for the gradient and then ask you to interpret it. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food. And so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5:2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so 1 part is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. and that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this, and actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which is going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting, and you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0, and actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, bit of old time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. Two minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. So when conducting a survey, you've got to make sure that you are looking into a few areas. The first area is to make sure that your questionnaire is fair, that it's not swaying the person's opinion with leading questions. The second thing you need to be careful of is that your sample is what we call representative. It means that everyone from all different areas have a view. So for instance, if you were looking at investigating the school canteen and you only picked people who use the school canteen, then it's probably going to be swayed towards how wonderful the canteen is, rather than the people who don't go to the canteen, who probably don't go because they don't like the canteen or because they bring packed lunch. The other thing that you need to look for, and there's quite a long list, but the other main thing you need to look for is that your sample is big enough. If it's too small, then it can't possibly be representative. So when it says select 5 names, 5 people is not enough for a proper survey. So my answer to this is step 3, and I would say sample is too small. So we're given quite a basic diagram. We're given a pair of parallel lines and we're given 2 angles from them. And angles on parallel lines, there are 4 things you should be thinking about. So the first one is corresponding, those are F angles. The next one is alternate, which are Z angles. The next one has loads of names. It's co-interior, interior, allied, whichever your teacher says. And the last one is vertically opposite. Now, vertically opposite occur in other places as well, not just parallel lines, but that's normally the one that you will be using. So let's have a look. Well, what letter does that make? So if I draw out from the parallel lines, I always say it's the armpits of the letter. So if it's a Z, it's the armpits of the Z. And if it's an F, it's the armpits of the F. Well, this is like an upside down backwards F. So we know that upside down backwards F, any F angles are going to be the same. So I know that's 62 degrees. Now we've got to give a reason. So the reason is corresponding. Now I always got corresponding and alternate mixed up. So I don't know whether this will help you, but I always think cor F ponding and alternate. Please don't spell it that way, but I just literally bung the letter into the word and I've never got them muddled up since, so that might help you. The other one, the C angle, are not equal, so these ones here are not equal, they add up to 180 degrees. So just be careful with that. The rule of thumb is if you're guessing and they look the same, even if it says it's not drawn to scale, if they look the same, then if you have no other memory of what they're likely to be, if you forget about angles on parallel lines, just write down the same angle. If the one's acute and one's obtuse, just take it away from 180 degrees and maybe you'll get some marks. But hopefully you'll remember the corresponding alternate, co-interior or interior or allied, and vertically opposite. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that on a calculator. 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018. But you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now, the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%, and then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022. So times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I'm rounding it to the nearest penny. Okay, so it says which account will give her the most money. Well, looking at that, it's going to be the super bank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be the super bank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here, because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now, with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator, and I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's two decimal places, so the line goes down here and we've got 168.28. Now just be careful that you add on the extra bit. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is we want to do, I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, and the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. So the first thing we're going to do is fill out the table. And so when it's x cubed plus 10, I'm just going to cube the x and then add 10. So 0 cubed plus 10 is just 10. And I always start off with 0 because it's normally the easiest. Then I go for the positive numbers. So 1 cubed is 1, plus 10 is 11. 2 cubed, so 2 times 2 times 2 is 8, plus 10 is 18. And 3 cubed, 3 times 3 is 9, times 3 is 27, so that's going to be 37. Now minus 1 cubed. Now some people think that minus 1 cubed will be a positive number, but it's minus 1 times minus 1, which is 1, times minus 1, which actually is going to be minus 1. So it's minus 1 plus 10, which is going to be 9. And then minus 2 cubed is going to be minus 8 plus 10, which is going to be 2. So when we plot this on the graph, minus 2 is going to be at 2, minus 1 is at 9, 0, 10, 1 is 11, 2 is 18, and 3 is 37. Okay, and you want to try and join these up with a curve. It looks like an S, the cubic, like that. Sometimes you get a dip like that. On this one you don't. So let's try and join these up with one straight line. I've already broken that rule. Oh, it's not very easy on this. And I would say that that's good enough. There's a little bit of wiggle there, but I think I can get away with that. The important thing is it goes through all the points and it's just one straight line. You don't do any feathering, and feathering is where you go like this. You know, I've exaggerated it slightly, but you just want to draw one line. Okay, so it says use the graph to find out the value of x when y is 15. So what I'm going to do is I'm going to draw a line across where y is 15. So y is 15 here, and the solution is going to be where the two lines hit. Now I think that's 1.7, so I'm going to go for 1.7 because it asks for 1 decimal place. Now normally with drawing questions, because people draw slightly different, normally there's a little bit of leeway in it, as long as you've used your graph and you've shown the examiner that you've used that line there. Well, I hope you found that video useful, and I hope there's elements of topics that you weren't so sure about before that you're happy with. As I said to you at the start of the video, please go on to onmaths.com and have a go on the resources we've got there. We will be releasing a paper 3 maybe before paper 2 comes out, but definitely after, so we can remove the paper 2 topics. Don't also forget that the examiners, the AQA, EdXL, OCR, all of the exam boards have said that topics can come up again, so don't fully rely on this. Use this as part of your revision, not solely your revision. Okay, but I think that advice is pretty obvious. As I said at the start of the video, if you like this video, please click like. If you really like it, want to see more from us, please click subscribe. Thank you very much.